So yesterday we learned about a trigonometric function, and its name was tangent. We know, we wrote down in our notes that the tangent ratio is opposite over adjacent. Opposite over adjacent, opposite over adjacent. We also learned we learned that there's some trig anatomy. There's a certain way to set up the equation. And the way that we set up an equation to solve for a missing angle or a missing side is first we write the trig function. Yesterday, we knew it was always tangent, so we would write tan every time. Then we learned in the parentheses, the only thing allowed is the degree. You don't put anything else in those parentheses. It's reserved. It's like reserved seating. Only certain people can sit there, or reserved parking. That is reserved for the degree symbol, degree. And then we put opposite over adjacent. So compared to 37, x is opposite, and 24 is next to. It's adjacent. So opposite divided by adjacent. Then we learned there were three scenarios. Scenario number 1, x is in the numerator. That's this scenario. We multiply. Scenario number 2, x is in the denominator. It's an alliteration, denominator divide. Scenario number 3, x is in the tan function, and in that case we press second tan to get to inverse tan. Okay, anyway, so x is in the numerator, so we are going to multiply. 24 times tan 37. You do want to be in the habit of putting the side first, the number first, not the trig function first, okay? And that's because it'll work every time if you do it that way. 24 times tan 37, we get 18.09. I told you that this was the unit of rounding. We're going to be rounding a lot, so make sure you know your rounding rules. This was 18.085, so the 5 bumped the 9 up. I just decided to do nearest hundredth. I didn't even tell you that. All right, next one. In number 2 and 3, be careful. It's not asking for the angle A. It's just asking for the tangent of A. So in number 2 and 3, you are not going to touch your calculator. You're not going to use the tangent button at all. Okay? The tangent of angle A. I want opposite divided by adjacent. Opposite divided by adjacent. The answer is 3. The tangent of B. We know the tangent of B will always be the reciprocal of the tangent of A, so we can simply reciprocate it, or we can actually do, let's see, 7 over 21, but it will reduce to 1/3. I don't really have to show the answers on the recorded lesson anymore because the answers are going to be posted every day, but I do understand that some students can't check the internet every night to check their answers, so I will continue to show it in class for just a few minutes. Looking at the tangent homework and looking at number 7, when it says to express the tangents of A and B as ratios in simplest form, when you hear ratio, you should think divide, you should think fraction. I'm dividing something, and my answer should resemble a fraction. That's what a ratio is. I am not going to press the tangent button at all. We did one in our warm-up a lot like this. The tangent of A. So I look at angle A. This is where Bob is, or Edgar. I want what's opposite of A, which is 40, and then I want what's adjacent to A, which is 9. What you had to write in your notes yesterday was opposite over adjacent, and you just follow that rule over and over. What's the tangent of B? 9 over 40, because opposite of B is 9, and adjacent to B, adjacent to B is 40. We don't use the 41, because it's the hypotenuse. So it can't be the adjacent one because it's the hypotenuse. Number 12, when you solve a problem like this, you want to always begin by writing your equation. You write the word tan, in parentheses, you put the angle. That's the only thing allowed in the function. You have to put the angle every time. By the way, if in the future, if you're given 2 angles, you just pick one of them. It doesn't matter which one you pick. That's going to be where you're standing. That's your perspective. So our perspective is at 26. What is opposite of 26? 6. What's adjacent to 26? X. Then you ask yourself, where is X? There's 3 scenarios. Numerator, denominator, or in the trig function. In this case, it's denominator. That's an alliteration. Denominator divide. 6 divided by tan 26. Yes, you have to put the number first, not the trig function, the number, the side length first. Number 15, you start just like we started the previous one. You write tan. Then in parentheses, the only thing ever allowed is the angle. Angle only. Nothing else allowed. Now we're standing at that angle. Here's our perspective. To us, what is opposite? 8 is opposite, and 13 is adjacent. We were nice to you. We didn't put other numbers on there to confuse you. I mean, you had the opposite and the adjacent given to you only. All right, how do you get x out of the trig function? The opposite of tangent is inverse tangent. So you press second, tan, and then you type 8 divided by 13. Number 16, find the measure of angle D. Okay, so the thing about trig is that there's usually 3 things involved. 2 sides and 1 angle. 3 things. To do trig, you have to know 2 out of those 3 things. So you have to have 2 pieces of information, whether it's 2 sides or a side and an angle. You have to have 2 pieces in order to find a missing side or angle. Now, if I look at triangle BCD, I'm trying to find angle D. I don't have 2 things. I have 24, and that's all I have. I can't do trig with simply a side length. It's not enough information. So I'm going to look over at this triangle, triangle ABC. And in this triangle, I have 2 things. I can do trigonometry and find out everything I want to about the pink triangle. Everything. Now, the only thing that matters to me, the only thing that the pink shares with the green is this side right here. I'll call it A. That's not a 9, it's an A. Okay? Once I know A, then I'll know 2 things about the green triangle and I'll be able to solve for X. Here we go. All right, so I'm going to go quickly because I've already explained all the other ones in depth. Tan of 32 equals opposite over adjacent. That's in the numerator, so we're going to multiply 36 times tan 32. So we go to our calculator. 36 tan 32, and we get 22.4952, blah, blah, blah. Now, don't round it yet. We don't want to round as we go, because then we get further and further away from the right answer. So I'm going to keep quite a few decimal places until I get to the very end. I can even just keep it sitting in my calculator and use it in my next step, okay? I'm going to keep it sitting here. Alrighty, so now I'm going to work in the green triangle. I'll use green for green triangle. Tan of, what's my angle? You could call it D or X, equals opposite over adjacent. Opposite over adjacent. And so X is in the tan function. I'm going to do second tan. So I'm going to do second tan, and then I can grab my last answer. I can push answer divided by 24, or I can type in the 22. It's up to you. And you get 43 degrees. Number 18, the angle created by the horizontal. You need to know what a horizontal is. Horizontal, vertical, horizontal, vertical. By the horizontal and straight line distance from the top of the shorter building to the top of the taller one is 20 degrees. That is a fancy way of saying that this angle is 20. Horizontal and the straight line distance. There we go. How far apart are the 2 buildings? How far apart are the 2 buildings? Remember to do trig? To do trig, you need 2 pieces of information. Right now, I only have 20 degrees. That's all I have. So I need to use the 80 of the taller building, the 68 of the smaller one, and I need to subtract them. 80 minus 68. Now we have 2 things. We have 12, and we have that 20 degrees. Tan of 20 equals opposite over adjacent. Denominator divide. 12 divided by tangent of 20. Okay, we have 2 more ratios today. Yesterday we learned that tangent was opposite over adjacent. Today, you can write down what the sine and the cosine ratios are, and then we will talk more about them. So the sine has its own ratio. It is opposite over, look, we're using the hypotenuse today. The cosine ratio is adjacent over hypotenuse. Remember, these are all just comparisons of sides of triangles. These comparisons help us solve for missing sides. And really, the basis of trigonometry, the math behind trig, is simply similar triangles. That's what trig is. It's using similar triangles. All right, let's practice using our new proportions, our new ratios, rather. All right, it wants the sine of A. Just like in the homework, I don't want you to press the sine button. I don't want you to do any math other than reducing a fraction. Okay, sine of A. So we are at angle A. That's our perspective. And the sine ratio says opposite over hypotenuse. So what is opposite of A? 6. And what's the hypotenuse of the triangle? 10. We would never leave our answer like that. So we would divide both of them by 2, 3 over 5. Now we want to do the cosine of A. Cosine is adjacent over hypotenuse. So this time we're going to grab the 8. The hypotenuse is still the hypotenuse. The hypotenuse is constant. It will not change. Okay? 8 divided by 10, and that reduces to 4 over 5. 4/5. All right, so a lot of you have heard of this acronym before. In fact, when you ask your parents or someone older, what do you remember from geometry? They might literally say, all I remember is SOHCAHTOA. That's all I remember. They might not even know what SOHCAHTOA stands for, but they sure do remember this acronym. Please write it down on your paper. I want you to memorize how to spell it, because if you spell acronyms wrong, then they're not much good to you. But if you know how to spell SOHCAHTOA, you will not have to memorize all of those ratios that you wrote down in your notes. You memorize simply the acronym, and then you know that sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And you can picture a toe soaking, which is kind of weird. But anyways, SOHCAHTOA. All right. A big part of trigonometry is figuring out which function to use. If you can't choose the right function, then you cannot even begin to solve for a missing side using trigonometry. So the half the battle is choosing the function. What you do is you take the angle. This is your perspective. This is where you're standing. To you, 18 is opposite. And then, of course, x is the hypotenuse of the triangle. So in SOHCAHTOA, which one involves an O and an H? Sine. So that one, the answer is sine. You would choose the sine function. All right, next one. Think about what you would choose. Here's the angle. Opposite, adjacent. So it's the TOA part of SOHCAHTOA. That would be our tangent function. You doing okay? Next one. 61 degrees. Opposite, because opposite across the triangle. And non-adjacent, hypotenuse. So that's the SO part of SOHCAHTOA. So it is sine again. Here's our angle. 70 is next to, it's adjacent, and x is the hypotenuse. So adjacent and hypotenuse, that's the K part of SOHCAHTOA. So you get now how to choose which function to use. All right, I'm going to let you draw this picture in your notes, and we'll solve some simple ones before we solve some more complex ones. Here we go. Which one shall we choose? We've got our angle, it's 53, x is adjacent, 12 is the hypotenuse. So adjacent, hypotenuse, cosine, you are the winner. So we write down cosine. The only thing ever allowed in parentheses is the angle, cosine of 53. And then SOHCAHTOA puts it in order for you. A goes first, so that's the numerator, adjacent over hypotenuse. So the order that it goes in SOHCAHTOA, that's the order that you'd go with your fraction. The first one goes on top, the second one goes on bottom. All right, x is in the numerator. Numerator means multiply because denominator means divide. So we are going to multiply 12 cosine 53, and we are getting 7.22. So the missing side, this side, was 7.22 units long. All right, look at this one. You don't need to draw the whole thing in your notes this time. Let's just practice writing the equation. Here's my angle. This one is opposite. This one is adjacent. OA. So tangent is our chosen function. Tangent of, we always put the angle, equals, O comes first, so opposite comes first, adjacent comes second. Opposite over adjacent. X is in the numerator again, so we're going to multiply again. 9 times tan 29. And we get a number super close to 5, but it's not quite 5. It's 4.99. That 8 will bump the 9 up. Okay? Next one, here's our angle. We've got opposite, and we've got, hypotenuse. You never write adjacent when it's the hypotenuse because hypotenuse trumps adjacent. So we're doing sine here. Sine of 34 equals opposite over hypotenuse. X is in the denominator. Denominator divide. You may not put the trig function first. You have to put the 9 first when you're dividing. Yes, the order matters when you're dividing. Not when you multiply, but definitely when you divide. Round to the nearest hundred, so I'm getting 16.09. How are we doing, guys? Next one, let's see. Here's our angle. You always circle the angle. That's always your perspective. We've got, let's see, opposite and hypotenuse. So we're using sine again, not sin, it's sine. You always put the angle in parentheses. This time, the angle is the unknown. Opposite over hypotenuse. Oops. Opposite over hypotenuse. The only way to undo sine is to do inverse sine. Inverse sine is the opposite of sine. So we press second sine, 17 divided by 25. Since it's an angle, we're in the habit of rounding those to a whole number. So it would be a 43-degree angle. I'm not going to say that it's going to be a whole number every time, but if the directions say to, then go ahead and do that. All right. There's only 2 examples left. If you're needing to leave, there's 2 examples, okay? Okay, so we're trying to find x. If I look, remember, you can only use trig on right triangles. We don't know if that big triangle is a right triangle or not. It hasn't been confirmed. So we're not going to try to use trig on the large triangle. We know we can use trig on the green triangle, and we know we can use trig on the pink triangle. Now remember, you can only use trig if you know 2 things. You have to know 2 things. So in the green triangle, we only know 1 thing. We only know the angle. We are not going to start in the green triangle. We're going to start in the pink triangle. All right, so let's look at the pink triangle. What would be most useful to find from the pink triangle that would help us with the green triangle? Well, it would be the shared side, right? I'll call it A. We're going to find A. We're going to find that shared side. All right. Always circle the angle. Compared to the angle, we have opposite and adjacent. Opposite and adjacent. So we're going to use tan. Tan of 39 equals opposite over adjacent. Where is the variable? Denominator. Denominator divide. 6 divided by tan 39. 6 divided by tan 39. We get 7.40938, so on and so forth. Remember, when that's not your final answer, keep the decimal as long as you can. It's a stepping stone. It's not the end. So do not round as you go because you'll get further and further away from the right answer. So A is, I'll just keep that mini. Alrighty, now we're working with the green triangle. In my green triangle, this is my angle. I have opposite and I have hypotenuse. I have opposite and I have hypotenuse. So sine is the winner in my green triangle. Sine of 46 equals opposite divided by hypotenuse. Where is the variable? It's once again in the denominator. Denominator divide. All right? So you can just take whatever number is sitting in your calculator, the 7.409, you can press divided by sine 46. If you got the same thing as me, you should have gotten 10.3. Okay, weird things happening with the cameras right now. Last problem of the day. Last problem. You're looking for that angle. If this is drawn to scale, that's an obtuse angle. So you're looking for that obtuse angle. You never use trig if the triangle is not a right triangle. So you want to make sure that you're using trig on a right triangle. You do have to be a little creative. There's multiple ways to solve this one, but the easiest way to solve this one, and I wish I had time for you to kind of stop and think about it, the easiest way to solve this one is to look at the large triangle. Do I know two things about the large triangle? Yes, I do. I know 7 and I know 16. So if I know two things about it, I can use trig. What I recommend is that you find A, this angle right here. If you find A, will you know X? Absolutely. Triangle angle sum theorem. If you know A, you just add them up and subtract from 180 and you are in business. All right, let's do it, guys. Let's find A. Compared to A, 7 is opposite and 16 is adjacent. Opposite over adjacent. So katoa, opposite over adjacent. Alrighty, the opposite of tangent is inverse tangent. So I'm going to do second tan. 7 divided by 16. 20, if we round it to a whole number, 24-degree angle. If that's a 24-degree angle, we can add it to 20. We can subtract it from 180, and we get our missing angle. So we didn't have to do trig twice here. Yes, it was a two-step problem, but no, we didn't have to do two trig equations. Good thing for that triangle angle sum theorem.